Hi, third graders. We are ready to start our next math lesson today. Today we are working on math lesson 12, continuing to work on area. And our lesson objective today is that we are going to solve word problems involving area. And our I can statement is the same. I can solve word problems involving area. So this would be like where we're using our RDWW, like we worked on in our past couple of units, but this time we're going to work on RDWW with area. Before we start our problem set today, but just to show you, this is what our problem set looks like today. So it's lesson 12 problem set. So you can grab that. You could have a highlighter handy, and that's it. We don't need our ruler today. So just your pencil, your problem set, and probably a highlighter today, okay? All right, so before we start, I just want to do a couple of little math slides to get our math brains warmed up. If we look at the first one, if we look at this, it says, say the area of the rectangle and what's the length of the rectangle. So we can see that the area here is 12 square units. So that means if I were to fill this up with tiles or squares, there would be 10 squares that would fill this up. So remember, area is how many square units does it take to fill up a shape. So this would be 10. So our area is 10. And we know that this side length here is 2 units, but we're missing this side length here. So we could say 2 times what equals 10, which is what we have right here. So 2 times blank equals 10. You can write this on a piece of paper or a whiteboard or just mental math. So think about what goes in there. You can count by twos until we get to 10, or maybe you know the answer. 2, 4, 6, 8, 10. So my missing side length is 5 units. Good. Let's look at another one. And I can fill that in right down there. 2 times 5 units equals 10 square units. Remember, with our label with area, we want that square units in there. If I look at the next one, okay, same idea here. I know that the area of this whole rectangle is 8 square units. I know that the shorter side length here is 1, and I'm missing this longer side length up here. So since I know the area, I can say 1 times what equals 8. 1 unit times blank units equals 8 square units. Think about what would go in there. Again, you can write it down on a piece of paper, whiteboard, or mental math. What do you think goes in there? Did you come up with 8, right? Because we know that 1 times 8 equals 8. All right, let's look at the next one. So for this one, we know that the total area is 15 square units. We're missing the shorter side here. We know that the longer side is 5, okay? So we have blank units times 5 units equals 15 square units. So blank times 5 equals 15. Think about how you would solve that one. And what did you come up with? If I count by 5 till I get to 15, I've got 5, 10, 15. Did you come up with 3 for your missing side length? Good job. So 3 units times 5 units equals 15 square units. Let's do one more. And I'm hoping that these are becoming kind of easy for us as we move along, right? Especially if we know our multiplication or our counting. Okay, so for the last one here, we know that the area is 18 square units. I know that the shorter side is 3 units, and I'm missing my long side up there. So I can say to myself, 3 times what equals 18. So 3 units times blank units equals 18 square units. You can count by 3 until you get to 18. So think about that for a minute. If you want to pause it and come up with that, you can write it or just do mental math. What did you come up with? Did you come up with 6 for that missing side length? Good job. So if we count by 3s, 6 times we would get 18, right? Good job. All right, I think I had one more there, but I'm going to skip past it. And we'll go right into our problem set for today. Okay, so again, we are on lesson 12 problem set. Go ahead and put your name and date on your paper and show me that you're ready to roll. Okay, so again, we have word problems. So we are doing RDWW. And just to review what those stand for, again, we have read, draw, write. Okay, and if I look here and it says Will you read this with me? Okay, here we go. Each side on a sticky note measures 9 centimeters. What is the area of this sticky note? Okay, so I'm going to look at that first sentence again for my read. Each side on a sticky note measures 9 centimeters. I have that clue word there. What's that clue word that I have there? Each. And I don't have my highlighter right here, so I could grab it, but I'm just going to circle that just so we see it. So you boys and girls give your highlighter, go ahead and highlight that word each, or if you don't have a highlighter right on hand, just go ahead and circle it so we can make note. Okay, and then we want to know what is the area of the sticky note. All right, so there's our read. Next comes the draw and a sticky note. So if we think about a sticky note like a Post-it note, what shape is a sticky note or a Post-it note? It's a square, right? So let's draw a square. Okay. And it says each side on a sticky note measures 9 centimeters. So this side is 9 centimeters and this side is 9 centimeters. I want to find the area. Do I need to put a 9 on all sides? I don't need to, right? Because when I'm finding the area, I just need to know these 2 side lengths here, or 2 of the side lengths, and then I can put my time sign right in the middle of them, and that tells me the equation that I need to use to solve it. Okay, so I have my picture, and it tells me that each side of the sticky note measures 9 centimeters, so there's 9 and 9, and my label is going to be centimeters, so I'm going to underline that, and I'm going to check off my draw. Next comes my right of a number sentence. So I've got 9 times 9 equals blank. And to solve that, maybe you already know it. If you want to pause it and solve it, or we can sing our 9 song together to solve it. And even if you already know it, we can do our 9 song together too, okay? So get your counting fingers ready and let's count by 9s 9 times. Ready? 9, 18, 27, 36, 45, 54, 63, 72, 81, stop. So what did we get up to? 81. So we have 81. Do we just leave it as 81? Nope, we need to give it that label. Do I say 81 centimeters? It's area, right? So we need 81 square centimeters. And cm is our abbreviation for centimeters. We can check off our number sentence. And that last W is to write a word sentence. So for the word sentence, I go to my question, which says, what is the area of the sticky note? So the area with a capital T, those 3 lines mean capital, right? The area is 81 square centimeters, period. And I can check off that last W. What do we think? Very similar to what we worked on in our last unit, right? Except this time we're just calling it area. Good. All right, let's take a look at number 2. Put your finger or your pencil on Stacy and read this with me, please. Okay, this says Stacy tiles the rectangle below using her square pattern blocks. So here's her rectangle, and it showed tiled, so it already has the squares built right into it, and these are her square pattern blocks. And if I look at A, it says to find the area of Stacy's rectangle in square units. So that's kind of like the task, right? So I want to find the area of Stacy's rectangle in square units. Then, so this is like the first thing that I need to do. So I'm going to put a 1 right there. Then, that's the next thing I need to do. Draw and label a different rectangle with whole number side lengths that has the same area. So I want to find the area of this rectangle here. And then I want to make another rectangle that has the same area but different side lengths. So I'm not just going to use the commutative property and flip-flop. I want them to be completely different side lengths. So let's read B, and then I'm going to let you, if you want to go ahead and pause, if you're feeling pretty good and confident, you can pause and work on number 2, the parts of number 2 on your own, okay? So B says, can you draw another rectangle with different whole number side lengths and have the same area? Explain how you know. Remember, explain means that you need words in your answer, okay? So if you feel pretty confident, you can go ahead and try number 2. You're finding the area, you're finding another rectangle that has the same area but different side lengths. And then part B is you're finding see if you can find even another one that has the same area. So if you feel good, go ahead and pause and work on those. Be sure to check back when you're done to see if our answers match up, okay? And if you want to stick with me to try this one out, you can definitely do that, okay? All right, so we have Stacy's rectangle. Find the area of Stacy's rectangle in square units. So I can count the squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I can also label the side lengths. I have 3 rows times 4 in each row. So it would be 3 times 4 equals blank. We can count by 3s. We can count by 4s. I'm going to count by 4s 3 times. Ready? 4, 8, 12. So the area there is 12. And it would be 12 square units, right? So I'm looking into the problem for my label, and it just says square units. So 12 square units, UN period. So this one equals 12 square units. So I did that part. And then it says, so I can even put a 1 right there, right? Because I know that there was 2 parts to this. Draw and label a different rectangle with whole number side lengths that has the same area. So for the second part to this question, I want to have another rectangle that also has an area of 12. So to think about that, I can think to myself, what times what equals 12 square units? So what are 2 other numbers that I can multiply besides 3 and 4, or 4 and 3? Because remember, we want completely different numbers that would equal 12. What did you come up with? Did you come up with 2 times 6 or 6 times 2? That would definitely work, right? So I'm going to draw that rectangle. So I'm going to go down 2 and over 6. I'm just kind of like estimate that. I don't need to measure because I'm going to just label it to kind of represent. So this side would be 2 and this side would be 6. And then the inside, the whole area would be 12 square units when I multiply those together. Does that make sense? And if you're checking, did you have that too? And if not, if you didn't have this one there, then maybe you're going to have the one that I'm thinking that I'm going to put down here. Because let me just make sure that I answered everything here. So find the area of Stacy's rectangle. Check, we did that. Draw and label a different rectangle with whole number side lengths that has the same area. We did that. So check and check. So let's look at B. Can you draw another rectangle with different whole number side lengths and have the same area? So I want different side lengths in 3 and 4 and 2 and 6. Is there anything else we could multiply? Something times something and have it equal 12. And I'm going to write in my square units. What else could we multiply that would have an area of 12? This is what I was wondering. Did you come up with 1 times 12? That's one that we forget a lot. Remember I told you that on one of our other lessons together? A lot of times we forget that we can multiply a number times 1 to get that area. So that's kind of one that we could always have. So we shouldn't forget about that one, right? And it says, can you draw? So let's draw that. So if it has a side length of 1, it would be skinny, right? And then the other side length of 12, so that would be pretty long. So this would be 1 there, obviously on the short side, times 12. And it would have an area of 12 square units. Let's see if I answered all of this. Explain how you know. So now I need to use words. So can you draw another rectangle with different whole number side lengths and have the same area? So our answer is yes, because we did do that, right? So yes, comma, 1 times 12 also equals 12, period, right? So, because that's what it was asking. Can we draw another rectangle that would have the same area? And we said yes, 1 times 12 also equals 12. If you were checking this, if you did this on your own, maybe you put the side length of 1 times 12 up here equals 12 and you drew this here. So if you drew 2 times 6 down here or 6 times 2, yes, comma, 2 times 6 also equals 12, or 6 times 2, either way. Okay, so you could have put those in either place there. Okay, how are we doing with that? Everyone okay? Go ahead and flip it over onto the back when you're ready. And on the back, so it says for number 3, an artist paints a 4-foot by 16-foot mural on a wall. And we see that here, right? So there's the 4-foot by 16-foot. Look at this right here. This is split up into 4, and there's the 6. But total, 4 or 10 plus 6 equals 16. So they took that mural and they broke it. Do you remember what that property is called? When we take something and then we break it and we can find the total of each part. What property is that? It's kind of a big one. Distributive property, right? So it says, what is the area? What is the total area of the mural? And we can highlight that total. And then it says use the break apart and distribute strategy. So again, it's telling us to use that distributive property, right? Okay, so we have side length of 4 here. And then it was 4 times 16, but they broke that up into 10 and 6, right? So there's that 16, 10, and 6. So this side here would be 4 times 10. And what's this side over here? There's my 6. What would go right here? It would be a 4 right there, right? Because opposite sides of a rectangle are equal. So if this side is 4, then this side is also 4. So my equation for this side would be 4 times 6. Okay? So for this side here, we have 4 times 10. What is 4 times 10 equal? We'll figure that out in a minute. So for this side, we have 4 times 10 plus, and this side is 4 times 6. Okay? 4 times 10, we can count by 10 4 times, right? And maybe you already know it like that, which is great. So, but if not, let's count by 10s 4 times, and let's count by 10s anyways 4 times, just to practice. Ready? 10, 20, 30, 40. Good, so this part here is 40. Okay, so 4 times 10 is 40. I'm going to write that right underneath it. And for this side here, we have 4 times 6. We can count by 4s 6 times. We can count by 6 4 times. And maybe you know, which is great. Let's count, though, to practice. Let's count by 6 4 times. Ready? 6, 12, 18, 24, stop. So 4 times 6 equals 24. So we have 40 plus 24. And maybe you can solve that mentally. Let's just, and even if you did solve it mentally, and let's talk about how we can solve that mentally too, actually. So if I think of 40, I have 4 10s, 0 1s. If I think of 24, I have 2 10s and 4 1s. So let me think about this, if we can solve it mentally. Let's talk through solving mentally. So 40 has 4 10s and 24 has 2 10s. So what's 4 plus 2? 4 10s plus 2 10s would be 6 10s, right? So I'm going to put a 6 in the tens place. And then we have 0 plus 4 is 4. Okay, so we think it's 64. Let's write it out just to double check. 40 plus 24. 0 plus 4 is 4. And 4 plus 2 is 6. So yeah, our answer is 64 what? Its area, so we need to give it a label. 64 square feet, right? 64 square feet. I'm just going to circle it because we've got a lot going on there. Okay, and I didn't write RDWW. I just turned that light on to see if that gets any better for us because it seems like it's kind of flickering a little bit. We'll give that a try, okay? So we didn't put the RDWW, but we've pretty much been doing it, right? We used the drawing that was already there, or we did our read, sorry, and then we used the drawing that was already there. I forgot to put 24 in there. We wrote a number sentence, so the last thing would be our word sentence, right? So what is the total area of the mural? I look at this question I underline. So the total area is 64 square feet. Again, we need to make sure if it's area that we give it that label, right? And it has to be square feet. because we're filling it with square tiles, right? Good. Okay, and then we can check off that last W, and we're done with number 3. All right, let's look at number 4. Are you ready to look at number 4? Put your pencil or your finger on number 4, and you can read it with me, okay? So Elena, ready? Elena tiles the 3 figures below. She says, I'm making a pattern. 1, 2, 3, there's her 3 figures. And it says to find the area of Elena's 3 figures and explain her pattern. And then for part B, we want to draw the next 2 figures in Elena's pattern and find their areas. So first of all, it says to find the area of Elena's 3 figures and explain her pattern. So let's do that. So if we look at the small one first, let's go ahead and label our side lengths. So this side length is 2, and this side length is 2. What goes right in the corner? The times sign, right? And I could do 2 times 2. I could also count 1, 2, 3, 4. So the area of this one is 4 square units because it doesn't say anything else, right? So I'm going to put right under it 4 square units. Nice and small. All right, look at the next figure. So let's label our side lengths. So this side length here is 3, and my side length across the top is 3 because there's 3 in each row, times side in the corner. And I can touch each one and count. I can skip count by 3s, right? If I know 3 times 3, I can just automatically solve that. I'm going to skip count by 3s 3 times. 3, 6, 9. So this one is 9. So the first one was 4 square units, and this one was 9 square units. I'm going to fit it in really small. All right. And then go ahead and label this last one. So label the side lengths and then find the area of this last shape. Let's see how you do. I'm going to kind of fill it in, but I'm not going to say anything. I want you just to kind of fill it in as we go, okay? Did you get 16 square units for that one? Good. Okay, so if we look at A, it says find the area of Elena's 3 figures and explain her pattern. So we see the 3 areas. The first one is 4, 9, and 16. So I'm just going to kind of rewrite my number sentences. So 2 times 2 equals 4 square centimeters. And then we have 3 times 3. I'm going to write them right under each other. Equals 9 square centimeters. So maybe kind of write small so we can fit it in. And then 4 times 4 equals 16 square centimeters. Did you get 16 also there? Okay, so now that we have all those listed, it says to find the area, which we did, and explain her pattern. There's that word explain, which means that we need to use words. What's her pattern? What's happening there? Pause your video and take a look at her pattern. We wrote those number sentences there as well. So pause it and think if you can think in your head, what is happening with Elena's 3 figures as she draws them? So pause and think about that for a minute. Okay, coming back together, what did you think? What pattern are you seeing? One pattern I'm seeing is that we have 2, they all have 2 rows. Well, the number of rows and the number in each row is the same, right? And then it's increasing by 1 each time. So here we have 2 rows and 2 in each row. Then we have 3 rows and 3 in each row. And then we have 4 rows and 4 in each row. Okay. I'm also thinking, well, let's see here. Is there a pattern with how we're increasing? So 4 to get to 9. So 4, 5, 6, 7, 8, 9. We added 5 there. And then from 9 to 16, what do we add to get from 9 to 16? So 9, 10, 11, 12, 13, 14, 15, 16. That's different, right? So that's not the pattern. So I would say if I'm looking, and what shape are all of these? They're all squares, right? Because they have the same number of the sides are equal. So they're all 3 are squares. And the number of sides, or the number of rows and the number in each row is increasing by 1 each time, right? So we can say that. So the side lengths, let's just kind of simplify it even more. So the side lengths are increasing by 1 each time, right? So explain her pattern. So the side lengths are increasing by 1 each time. Does that make sense? So writing the big long thing that we were kind of talking about of the number of rows, the number in each row, we can just say the side lengths are increasing by 1 each time, both of the side lengths, okay? And then part B says to draw the next 2 figures in Elena's pattern and find their areas. So if the first one we had side lengths of 2 and 2, then we had 3 and 3, 4 and 4, what do you think the next one would be? 5 and 5. And we want to draw the next 2 figures. So if the next one has side lengths of 2 and 2, then the one after that would have side lengths of, not 2 and 2, did I say 2 and 2? And this is 2 and 2, 3 and 3, 4 and 4. The next one would be 5 and 5, we said, and then the last one would be 6 and 6. So if you want to pause your video and draw in those next 2 shapes, you don't have to, I'm not worried about, the tiles being drawn in exactly, even if you just want to make them a little bit bigger to represent, right? That they are getting bigger each time, and label your side lengths and then find the areas here. Okay, so if you want to pause it, you can. Okay, I'm going to draw the next one. So it's 5, so it's going to be a little bit taller, right? And a little bit longer this way. And I'm going to label my side lengths 5 and 5. I'm not going to worry about putting those tiles in because I have these to represent it. And what is 5 times 5? 25, right? 5, 10, 15, 20, 25. So if that one has side lengths of 5 and 5, we said the next one would have side lengths of 6 and 6. So this one's got to be even bigger. It's a square, right? So I want to try to make it look like a square still. And my side lengths are 6 times 6. And do you know what that area is? If you already did this, what did you come up with for the area for 6 times 6? 36. Good job. Okay. And it says draw the next 2 figures, which we did, and find their area. So let's just write our number sentences here for the areas. So this one we had 5 times 5, which we said was 25. We need to give it a label, so 25 square units. And for the last one, we had 6 times 6, which we said equals 36 square units. Good. So we're all set with that. We have one more to go. We're doing so well. Okay, so for number 5, it says Jermaine. He's gluing some paper together. Will you put your finger or your pencil on Jermaine and read it with me? Okay, here we go. So it says Jermaine glues 3 identical pieces of paper as shown below and makes a square. So here's his 3 identical pieces of paper. Here's 1, 2, 3, and then he's making a square. And it says to find the unknown side length of 1 piece of paper, then find the total area of 2 pieces of paper. So this kind of seems like a lot, so let's break it down even more. All right, so he's gluing 3 identical pieces of paper, which we already looked, and those are making a square. Find the unknown side length of 1 piece of paper. And if we look right here, we want to find like this side length right here of 1 piece of paper. So they kind of drew that arrow there to show us that's what we're trying to find. And they put question mark because we don't know that. So we try to find how many centimeters that is. Okay. Then after we do that, we want to find the total area of 2 pieces of paper. So let's see here. All right. I know this whole top side length here is 9. And I know this whole side length here is 9. Not just this one and not just this one or not just these 2. This whole side length there is 9. But there's 3 of these and they're equal. So if this whole piece here is 9 and I need to break it up into 3 parts, a couple different ways I can do this. I could say, okay, my total is 9 and I'm dividing it into 3 parts. So what would that make each part? And I could count by 3s till I get to 9. If my mind didn't immediately go there, I could think of I could say, okay, what plus what plus what? When I add those 3 numbers together and they have to be the same equals 9, I could try some different numbers, right? So maybe I could try like 5, 10, 15. Well, that's way too much, right? If those were each 5s. I might say, okay, that's too much. Let me try 2. So 2, 4, 6. That's not enough if they were 2. So I need to try a little more. 3, 6, 9. That works, right? And plus, if we went here right away, if we said, okay, this total side length is 9, and there's 3 parts, so 9 divided by 3, I should think if I have that for an equation that I would count by 3s till I get to 9. 3, 6, 9. So my answer would be 3, which means each of these parts right here are 3 centimeters, right? So that means this right here, where it's asking that question mark, this is 3 centimeters. All right, so find the unknown side length of one piece of paper. We did that. Are we done? No. So then find the total area of 2 pieces of paper. So I'm going to draw a line to kind of separate. I want to find the area of 2 pieces of paper, so I'm just going to kind of cross that one out because here's a piece of paper and here's a piece of paper. So I want to say, if this top part is 9, what's my side length here? Maybe I'll put it over here since I've got some other stuff going on there. If this top part is 9, what's my side length for this whole part right here? Is it just 3? I need more than 3, right? Because just this is 3. If this is 3 and this is 3, what is this side length here now? 6, right? Because 3 plus 3 is 6. So that leaves me with that top side length of 9 times 6. And that would give me the area of just those first 2 pieces of paper, right? So we want to solve for 9 times 6. So do you know this already? We can just skip count. We can skip count by 9s. We can skip count by 6. I'm going to do 9s. You count it with me. So let's skip count by 9s 6 times. Ready? Counting fingers ready. Here we go. 9, 18, 27, 36, 45, 54. Stop. What do we get? 54. So 54 what? Do I just leave it at 54? I got to label. I've got to label. So 54 square centimeters. So these 2 parts right here are 54 square centimeters. Does that make sense? Okay. So we can think of this again. This would be like an RDWW, right? Sometimes we just go in autopilot that we don't even mark it. We just do it. So the last part would be a sentence. So find the total area of the 2 pieces of paper. So the total area is 54 square centimeters. There you go. And can I show you something else real quick? So that wasn't the only way that we could solve this, and maybe you even already thought of this, but we would know that 9 times, so if we think of this whole rectangle, right, 9 times 9 equals 81. So the area of this whole thing would have been 81, okay? So once we know that, and then we would say, okay, we want to know what the area of the 2 pieces of paper is, which means I'm taking this one away, which I already put the X to it, right? So I knew that this one piece, if this was 9 up here, then this was 9 down there. So that would be 9 times 3, which is 27. So this one right here is 27. So then since I'm taking that away, I could say, okay, 81 minus 27, right? Let's see here. And then I have, I can't do 1 minus 7, right? So I cross out the 8 and make it a 7. And then the 1 becomes then 11. And then I have 11 minus 7. So I could put 7 in my head and count up to 11. So 7, 8, 9, 10, 11. That equals 4. And 7 minus 2 is 5. So again, we get 54 square centimeters. Just another way to do it. And maybe that even makes more sense to you. So sometimes we can see different ways, and then one just makes more sense to us, and we can go on to that way. Okay? But super job today. We kind of took what we've been working on with area for the past couple weeks, and we brought it all together into word problems, which I think we've gotten really good at. So good job today, and I will see you for our next lesson.